Myself, P Patil, Assistant Professor, Civil Engineering Department, Walchand Institute of Technology, Solapur. In today's session, we are going to discuss a small problem on work energy principle. At the end of this particular session, students will able to solve the problems on work energy principle in what distance will body move as shown in figure. Next, attain velocity of 3 meter per second starting from a rest. Take coefficient of a friction. Take coefficient of a friction 0.3 between block and plane. So the figure that I mentioned, this is 45 degree, this is 30 degree. Two blocks are present like this. Here the weight of this block is 300 Newton and the weight of this block is 200 Newton. Acceleration means block moves in this direction, and for this particular block you may identify the distances. So here we are considering small pulley and this block is moves in this way. So it's your duty to identify the reactions, that is by using energy principle. So let's will modify this particular figure. Now you may consider the weight is present exactly in a vertical downward direction. So always it is present in a downward direction, but the blocks are inclined one. So two components are present. One, it moves in this direction. Second one, it moves in this direction. Similarly here also we are considering it moves in this direction. Now block rotates according to this way. So the directions that are mentioned here, so it moves upward direction. So the frictional force present in a downward direction, this is F1. This block is also moves in a downward direction, so the frictional force is present, this is F2. Next one, the normal reaction is present, this is your R1, this is your R2. The angles are mentioned with respect to x-axis, so the geometry it is in inclined direction. So we are considering this is your cos term. So here 300 cos 45, 300 sin 45. Here also 200 cos 30, and this term that is 200 sin 30. Now we are assuming here that it's analysis of a connected bodies, analysis of a connected bodies using using energy principle. Using energy principle. Here one more term we are considering, the whole body act as a single unit. So you may assume whole system as whole system act as a single unit. So the principle regarding energy, F into S is equal to m by 2 v square minus u square. Initial velocity, final velocity, weight, reactions we are considering in a horizontal direction, and this is the displacement is the. Let's you observe here. First we are calculating summation v is equal to 0 for first one block. So here you may consider the R1 is equal to 200 cos 30 is there. So 200 cos 30. Similarly, you may calculate for block number 2, that is R2. This is for 200 Newton block. This is for 300 Newton block. So R2 is equal to 300 cos 45. So you may calculate the value of R1 173.20. You may consider here Newton. The value of R2 is 212.13 Newton. Next, that is the value of, by considering the friction law. So F1 is equal to mu into R1, F2 is equal to mu into R2. So all of you know the value of mu, they have already given, it's 0.3. So F1 is equal to 0.3 into 173.20 and F2 is equal to 0.3 into 212.13. Let's do the calculation. The value of F1 is 51.96. The value of F2 is 63.63. Now F1, F2 is over. Our task is now, you may identify this particular value, that is we want displacement. So now here we are putting the value. F is nothing but all horizontal forces. How many horizontal forces are present? 200, F1, 300, F2. 4 forces are present. So we are putting this particular value in the equation. So you may observe this equation. According to the energy principle, F, how many horizontal forces are present? F1, it moves downward, minus F1, minus 200 sin 30 plus 300 sin 45 minus F2. This is regarding only F into S is equal to m by 2, that is W is there. So we are considering here W by 9.81 into 2, and now the initial velocity is 0 starting from a rest they have mentioned here. So 0 minus 3 square. 3, that is nothing but the initial velocity, final velocity they have mentioned here. Now let's we solve this particular solution or the statement regarding the problem. So minus, this is your F1, F2 is there, F1 is 51.96, here 200 sin 30 it comes 100, 300 sin 45 it comes 212.13, minus F2 is 63.63 into S is there is equal to, so this W is nothing but total weight 300 plus 200, so total is 500 divided by 9.81 into 2 into 3 square. So when we solve this particular bracket, so you'll get the answer. So minus 3.46 S is equal to minus 229.357. So minus minus get cancelled. 3.46 S is equal to 229.357. So the S is equal to 66.28 meter. So let's solve this particular things. The answers. So do the calculation, modify all these things, find out the value of S, and S we have calculated here, it comes 66.28 meter. So in the problem statement they have mentioned in what distance will body move. So that distance we have calculated here, it comes 66.28 meter. So to prepare this video, I have referred, these are the references. Thank you.